Express 5 sine x minus 12 cos x in the form r sine x minus alpha, where r and alpha are constants with r greater than 0 and alpha between 0 and 90 degrees. Use the results in part 1 to find the least value of 1 over 5 sine x minus 12 cos x plus 20. Write down a value for x for which this least value occurs. So here's the question then, summarised slightly. So part B, part 1 then. So here, let's have a look at this one. So here, what have we got then? 5 sine minus 12 cos. And that's going to equal this. So we can expand that using the compound angular formula. R lots of sine A cos B, sine x cosine alpha, minus, because that's the formula, sine A cos B minus cos A, so it's R lots of cos A, sine B. So that would be alpha, sine alpha, wouldn't it? So now let's equate the sines and cosine coefficients. So first of all the sines. So on the left we've got 5 lots of, on the right we've got sine x r cos alpha lots of. That's our first piece of information. Let's equate the cosines on both sides now, the coefficients of, minus 12 lots on this side. Cosines on this side, minus r sine x. Sine alpha, sorry. That's equation 2. So now we can do the standard thing. Square this and add them, we get r squared. So we square this and square this, we get 25. Plus this squared is 144. That's 169. So we can then square root both sides of this to give r equals the square root of 169 is 13. So there's r. Now we divide 2 by 1, don't we? So 2 divided by 1 gives... Now what I want to do first of all though is I'm going to times both sides of this equation by a minus to write it like so. So 2 divided by 1 then, sine over cos, the r's cancel, gives tan alpha is equal to 12 over 5, isn't it? So that tells us what alpha is equal to. It's shift tan of 12 over 5, which is 24 over 10, which is 2.4. Shift tan 2.4. So I've put it in here already. Shift tan 12 over 5 is 67.38. Let's do it to 2dp then. 67.38 degrees. So that's alpha. And we've got r. So answer then. The answer is equal to, it was r sine x minus alpha, wasn't it? R, which is 13, sine of x minus alpha, 67.38. There we go, that's part 1. Now part 2. So this thing here, we want to find out when this has a least value and for what value of x this least value occurs. So we've got 1 over 5 sine x minus 12 cosine x plus 20. That's equal to 1 over, now we can replace these two first terms by this thing here, can't we? 13 sine x minus 67.38 plus 20. So when looking at this fraction, the least value of this fraction is when the denominator is biggest. Since the sign varies between 1 and minus 1, this will be biggest when the sign is biggest, which is 1. 13 times 1 is 13, plus 20 is 33. 1 over 33. 1 over 33 is the smallest value. And that happens when this sine function is equal to 1. Now we know that sine of 90 is 1, so we can get the x value. So x minus 67.38 degrees must equal 90 for the sine of this to be 1, mustn't it? So x is equal to, this is just one value, move the 67 over to plus, 90 plus 67 is 157.38 degrees. So there's one possible x value where you get sine of this is 1, and that makes this the smallest value possible, being 1 over 33.